Here we go. Let's take a look at the warm-up problems. Now, here's kind of what we're going to be doing today, but I'm starting off very simple. Graph the function f of x equals negative 3x plus 2 on your calculator, and we're going to determine domain and range. Now, this should look familiar to you. F of x is yesterday we talked about that function notation. Let's take a look at this. And we should know the name. What is the name of the form of this equation? Slope-intercept form. I know it's very magical. So, do we really need the calculator to picture the graph? I mean, not necessarily, but I'm going to pull it up on the picture so we can talk about it. So let me pull up our graphing calculator here. Negative 3x plus 2. Let's hit a graph. Plus 2. Come on, plus 2. I swear I hit the 2. Oh, go cursor. 2. Here we go. Okay, so we all know it's a line. It's not exciting. There it is. Okay, so we're going to talk about domain and range today. First, just to recap yesterday, because we had some people gone. First, let's talk about, is this a function? And the answer to that question is yes. 2 ways to think about it. A, it passes the vertical line test. B, if you put, back to the equation, one number in for x, you get exactly one answer out. Okay, back to the picture. Now we want to actually talk about what the domain and range are. So domain, remember the x's. So I'm always thinking horizontally. How far left, how far right will this line cover? Well, remember, it's going to keep going off the graph to the left, off the graph to the right. So it's going to cover everything. So I'm going to put that my domain. Now, lots of ways you can write this. You can actually write the words all real numbers out. I find that kind of irritating and obnoxious. Have you seen this symbol? That means all real numbers. If you like interval notation, I think some of the Algebra 2 teachers use it. I don't know if they all do. You're from negative infinity to positive infinity. And I don't care which way you write the answers, and you'll see I kind of mix and match. Whatever makes sense to you, it doesn't matter to me. Okay, let's talk range. So range, remember, y-axis. Lowest to the highest. What's the range? How far down, how far up is it going to go? Yeah, infinite. All real numbers again. Or if you like the interval notation, got it. Okay. So that, of course, is very simple. Domain and range on a line. We're going to kick it up a notch. We're going to have some quadratics today, maybe some square roots, some fractions, some other types of expressions. Now here's a throwback to geometry. Now this comes into play in one of our application problems today. Find the volume of the cube with the side that measures 7 inches. Ooh, geometry. What is the formula for volume of a cube? Length times width times height. There we go. So we need the formula, of course. And what's nice about a cube, all the sides are the same. So, I mean, let's be smart. I'm not going to put 7 times 7 times 7. Let's just go 7 cubed in the old calculator. And what is 7 cubed? And I'm going to throw a label on that, inches cubed. Like, why are we doing this formula? So like I said, volume of a cube, volume of a rectangular prism, can't help myself with the geometry vocab, is going to come up in one of the problems later today. All right, moving on. Here's what we got today. So like I said, with the line, we're going to practice finding domains, and we're going to do range with some functions. We're going to get away from lines, something a little more exciting. Real life problems, that's going to be that volume situation. And I'm going to show you this at the end too. This is new too. Difference quotients. Now don't let it freak you out. What's difference mean in math? What operation? And quotient means, so we're going to subtract and divide all in one problem. Ooh, very exciting, okay? So it's just a lot of work, multiple operations in one problem. Okay, assume the domain of f is that set of numbers. Determine the set of ordered pairs that represent the function. Now remember, keywords here, domain. These are your x coordinates. So they want you to put -2 in for x, then they want you to do all those numbers in the set, -1, 0, 1, 2. So you need to come up with the y coordinates. How are you going to do it? Plug them in for x. That's as hard as it is. So -2 squared, 4. -1 squared, 0 squared, 1 squared, 2 squared. Now, just to relate it to yesterday, this is the same thing we did yesterday on the back of your homework. It's just a different style of answer. They want ordered pairs. Yesterday, I asked you to do it this style. I asked you to give it in function notation. It is the same thing. It's just a matter of how they want you to write the answers. Okay, same thing. We're going to use that same set of numbers for x. Get my commas in there. Okay. And let's figure out, we're going to do a little mental math here, the y's. -2 plus 1, -1, absolute value. -1 plus 1, 0, absolute value. 0 plus 1, 1, absolute value. 1 plus 1, 2, absolute value, 2, 2. 2 plus 1, 3. Got it. And again, it's the same thing as yesterday, different notation. Yesterday, I made you write it like this. F of -2 equals 1. We put -2 in for x, so we got 1 out for the answer. Same thing, just a different style, okay? Nothing crazy there. Do I need any work for these on your homeworks? Nah, you can mental math them, okay? All right, next up, easy, but sometimes the directions get people. Find all real values of x, such that f of x equals 0. So here's my question for you. Are you putting the 0 in for x or for f of x? Where does the 0 go, left or right? Read the directions close. It's going on the left. So we're going to put 0 in for f of x. You are solving for x. And you know I love a fraction in here. What lovely fraction do you get? Piece of cake. Circle it. Okay. But of course, you know I can't help myself. Now again, if they wanted you to write it ordered pair style, we got -1/5 for x. What was 0? What was y? Y is 0. So also that point, is that the x or the y-intercept? X, that would be on the x-axis. That's also your x-intercept. Boom, we found all sorts of stuff for one problem. All right, B, same thing, just, fraction of it. So again, f of x is 0. You are solving for x. Now, obviously, we need to get rid of the fraction. Nobody likes over 7. Let's multiply by 7, of course. 7 times 0, still 0. So one thing to think about. I honestly probably wouldn't have even done the times 7 step. Because think about a fraction. For a fraction to equal out to 0, the top has to be 0. 0 over whatever, 0. I would have gone straight to this, personally. Add 3, divide by 2. We're going to have 3 over 2. Which, again, is our x-intercept, since we have 0 for y. All right, take a look at the front page of your notes there so far. Anything too crazy on those first 2 problems we did? First 2 things. Let's talk about domain before you flip it. So we're going to talk about how you can calculate domain or find domain of a function. Now, there's 2 ways you can do it. And you know I don't care how you do it, as long as you can figure it out. We're going to talk about doing it from the graph. I'm also going to talk about doing it just algebraic. Whatever makes sense to you is what you're going to use. So, if we're going to do it, we're algebraically. Remember domain, your inputs. So I'm really asking you, what numbers can you use for x? What can you put into the function and you'll get answers out? That's what we're talking about. So of course, ask yourself, you put what you put in for x and you get a real number. So no imaginaries. We can't square root negative numbers. I'm just going to talk about this. So radicals always make me a little nervous because you can't square root a negative number. That puts you in the imaginary unit system. Fractions make me a little nervous too, because what number cannot be in the bottom of the fraction? Can't divide by what? 0. So I'd be worried about that too. So this isn't on yours. This is just kind of what I go through in my head. If I'm going to do it algebraically, I'm not going to look at the graph. I kind of just test the number line. I ask myself, can I put a negative number in and get an answer? Can I put 0 in and get an answer? Can I put a positive number in and get an answer? I just test the number line and see if they all work, if there's a problem, etc. So I'm going to do the first one just from looking at it, okay? So find the domain of the function. So I'm going to test the number line. Can you put a negative number in for x and would you get an answer? Yeah, we'll get one, sure. Can you put 0 in for x? Would you get an answer? Yeah, we'll get one, fine, okay. Can you put any positive number in and get an answer? Yeah, so right now I'm pretty sure the domain is all real numbers. Now, let's verify that on the graph. So just to show you that, y equals, let's type it in. Now, before I hit graph, you should know what sort of shape this is going to be. X squared makes what shape? Good, I like the gestures, parabola. This one's going to open down because of the -2 on the x squared. So I'm thinking about my parabola. Domain, x-axis. Of course, this continues off the screen. It's going to go all the way to the left, all the way to the right. It's going to cover everything. Also, if you look in the T-chart, if you scroll through the T-chart, you will see there's no error messages in there. Everything has an answer to it. It's all lovely and pretty, okay? So however it takes for you to figure out all real numbers, do it. Let's look at this one. So if I'm going to do it in my head, and think about the t's in both locations, I'm testing the number line. Can I put a negative number in for t? Will we get an answer? Most of them. Is there a negative number that's going to be a problem for me? Think about the denominator. You can't have what in the bottom? Yeah, -5 is going to be an issue because it's going to make the denominator 0. Okay, so I'm going to have to address that in a second. I'm still testing my number line. I did negative numbers. Everything but -5 is okay. 0. If you put 0 in, is that okay? We'd have 0 over 5, 0. Fine. Positive number. If you put any positive number in, will we get answers? Yeah, they'll be gross fractions, but we'll get answers, okay? So right now, I'm pretty confident. I'm going to say all real numbers. T this time, okay. Now, if I'm unsure, I'm like, I'm not sure. Let's check it on the graph. So I'm going to pull up my calculator. Y equals. Let's clear this out. I'm going to pull up my horizontal fraction bar so I can type it in and make it look exactly like that. Clearly, I'm going to use x so instead of the t. X. And we are going to do some graphs of these. So I look at that graph, and you might be like, oh man, how does I see from the graph we can't use -5? That might be a little rough to see. So we can see it's all the way to the right side. This is going all the way to the left. If you look in your table, what in the table tells you got an issue? What word? Error. We have an error message at -5. Because obviously that puts it 0 in the bottom, 0 in the line, and define. So you can always use a graph in the table to help your cause too, if you get stuck. All right, C. Oh, C. 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 Let's start at the bottom. What's the one number that's going to be an issue in the denominator? -6. Okay, because that's going to make 0. So I'm just kind of mentally filing that away. Got it. Now, the top concerns me too. Got a lot of concerns here. Because on the top, you can't square root what types of numbers? Negative. So, okay. All right, so I'm worried about this x plus 6. I need it to be positive. Now, let me ask you another question. Could you square root 0? What's the square root of 0, if I asked you? Square root of 0 is 0. Square root of 0 is 0. So we can't. So I'm going to put the equal to it. All right, solve this, big deal. So what I want to do is try to combine these thoughts into one final answer, okay? So here's the thing. Now, let's first talk about how you can use anything greater than or equal to -6. Like if you put -5 in there, you'll get 1, that's fine. -2 in there, we'll get 4, fine. 100 in there, we'll get an answer, fine, okay? But here's the glitch. I can't just write that down in my final answer because of this. You can't use -6 in the bottom. So when I put my final answer, yes, I'm going to write that inequality, but I'm going to yank off the equal to part because -6 is an issue in the denominator. So I'm going to say, oh, remember, x is greater than -6. And again, if you like the interval notation, you know I don't care. You're from -6 to infinity. However you like to write it, your case, okay? So that's probably the trickiest one of the day. Any questions on that? All right, cruising on. Here we go. So let's take a look at the graph and see if we can just do domain and range straight from the graph. So go ahead, let's punch that guy in. Y equals x squared plus 1. Okay, so obviously in here, we're not doing a lot of graphs by hand, so to speak. You can use your calculators. So to draw it, let's just pull up the table. It's pretty rough with all those decimals. And let's just pick a couple points and get a sketch of it. Like obviously I'd do 0, 1, and then I would just round that, like do -1, 1.4, positive 1, 1.4, and let's get it sketched. So let me give you a minute to get yours drawn. Clearly, I'm going to cheat here. And I'm just going to use the calculator picture. I'll give you a sec to get yours drawn. Doesn't have to be the most beautiful sketch, but mark it out. Now, as you're marking it, think about domain. How far left to right are you covering? Think about range, bottom to top. So let's get into it. Domain, how far left to right? All real numbers. You can write the words all real numbers, use the symbol. I use the symbol a lot. Or negative infinity to infinity if you like that. Okay, range. What's the lowest to the highest? What's the lowest? 1 to infinity. So I like the interval notation a lot of times because it's that short and sweet. 1 to infinity. Notice 1 has the bracket on it because 1 is a point on the graph that's included. Now if you're like, oh, I hate that interval notation, you could say, all real numbers, y is greater than or equal to 1. Either form, I don't care, I mix and match, all means the same thing. All right, you guys graph this one. I'll let you guys do it for a second. I showed you where absolute value is. Let's see if you remember. Testing the calculator skills today. Remember, absolute value is under your math menu at num. Like I said, I cheated. I got the graph on the next slide here for us. So hopefully you've got that marked out. Let's do domain and range. So just looking at the graph, how far left, how far right is the V going to cover? Everything, right? Also, if you just look at the equation, can't you do the absolute value of any type of number, positive, negative, 0? Yeah, I sure can. I sure can. Okay, range. What is the lowest to the highest? What's the lowest? 0. Highest. So that's why I kind of like the interval notation. It's just short and sweet. Low to high. Domain. Left to right. Bam. Got it. If you like, of course, the inequalities, real numbers, you would say y is greater than or equal to 0. Either style of answer is beautiful. I will take them both, not mark a single thing off. Any questions on that? All right, get ready for my artistic skills. Here we go. It's going to be good. So this is our application problem of the day. Now, this is very similar to the one in the homework. I literally just changed the number. Also, the one in the homework has a very lovely computer-generated printed picture instead of my hand-drawn one that I'm going to make for you. Let's do it. So, an open box is made from a square piece of material. Okay, I'm going to draw a square. I'm going to attempt to draw a square. 12 inches on each side, it says. Okay, here's my square. Back to geometry. Now, here's the fun part. We're going to cut equal squares from each corner and turn them up. Now, I don't know, so picture it, it's like origami gone bad here. You've got your piece of paper, we're going to cut the corners off, and we're going to fold them up. That's going to make like a tray box. Now, I don't know how much we're cutting off, so I'm just going to kind of draw equal squares in each corner. Now again, it doesn't specify how much you're cutting off the corners, so I'm just going to call it X. And it's a square, so they're all the same. It's like a coloring picture going bad. Okay, it's a lot of X's. Now, next up, it wants us to find an expression for the value. So that was that warm-up problem that we had to review our formula for volume, our length times width times height. So let's talk about that. I'm going to start with the length. Now, think about this. We're starting with our length of 12, and we're taking off a corner. You're taking off this corner. If I am removing the corners, are you adding or subtracting? Subtracting, yeah. So we're subtracting the left corner, you're subtracting the right corner. Now, I'm going to put that over there in my formula, but I'm going to combine that to minus 2x. So I'm going to say 12 minus 2x for the length. Now, width, I think is going to be pretty similar because the width is the same deal here. You got 12. We're going to take off the bottom corner, take off the top corner. 12 minus 2x. It's a square. I'm not at all surprised those are the same. Now, here's where it gets fun. What's the height? So remember, you've got this square piece of paper. You're cutting off those corners and folding them up. So if I fold up the corner, the height of it's going to be whatever you're cutting off here. That's going to be how tall it is. So x for the height. And again, you have a much nicer, prettier computer-generated picture in your homework. Now, we probably should simplify this here a little bit, maybe a little distributing, combining terms, make it look good. So I'm going to FOIL these together to start. So 12 and 12 minus 24x. And I know some of you can do the middles, combine them in your head, that's fine. Just writing it out for the love of math. Plus 4x squared. And of course, we still got to take the x through. Now, some of you can combine those like terms, take the x through all in one step, fine. I'm just going to write them out, step by step here. So I'm going to combine the minus 24 and minus 24 x's. And then I'm going to distribute x through. Now, you don't have to. This is just me. I like it, my answer, highest exponent to the lowest. So I'm going to put this 4x cubed first. I like it. You don't have to, but generally we always write them highest exponent to the lowest. All right, minus 48x squared. We've got it. 144x. Okay. We're almost done with this thing. But there is more. Wait, there's more. It wants the domain of this function. How about domains today? So let's talk domain. Last part of this. So at first I'm just glancing at this and okay, domain, what can I put in for x? Everything, right? Can I cube everything and square it? I'm like, wait a minute. It can't be that easy. First off, it's a word problem. And it has to make sense to this word problem. Now, x, of course, representing how much you're cutting off the corners. So you have 12 inches, and we're cutting off the corners. So we have to cut something off. So it has to be over 0. So that's my first thought. Okay, we're cutting something off. So we have to be more than 0. We can't have a negative number. That seems weird. You're going to cut off negative 4 inches. What does that mean? Okay. Now, the other thing I'm thinking about, there's got to be a maximum of how much you can cut off each side. How much is the max we could cut off each side? Could I do 2 inches and 2 inches? If I did 12 inches and 12 inches, I heard 12. What about 6 and 6? Because you have a total of 12. Now, can we do exactly 6 and 6? If I cut 6 off one and 6 off the other, what's left? So we can go up to 6, up to 5.9, 5. I mean, that'd be dicey to cut off, but we could, in theory, do it. So I'm going to say max of 6. So let's write this out, of course, in a nice mathematical notation way. Choices. You know I like the interval notation because it's short and sweet. From 0 to 6. Notice parentheses are not actually including 0 and 6. Parentheses mean up to 0, up to 6. If you like the inequality style. We're less than 6, we're over 0. Either one means the same thing, okay? So you have a very similar word problem in the homework. I literally just changed the number in a prettier picture, all right? So look back at your notes. That will help you for sure. Last thing I have for you, get ready. Difference quotient. So we're back to evaluating functions like yesterday. but it's a little bit of a step up. It's not just what's f of 2 where you just put 2 in, bing, bang, boom. Notice we have all these crazy variables. So here we go. So let's start with part A. Part A is nice and easy, f of A. Okay, I'm just going to put A in for those x's. That seems easy enough. 2a squared, 3a minus 1. That was really hardly worth me even writing. But okay, there it is. Got it. F of a plus h. This causes me a little anxiety because I have to put a plus h in for each of these x's. My device is right small here. Okay, let's write small. So I'm going to have 2 times a plus h squared. Okay. 3a plus h minus 1. Okay. Now, that doesn't seem that stressful, just rewrite all the x's with a plus h. But we have to simplify it. Order of operations, we got to square first. We cannot just go a squared plus h squared. You have to write it down twice and do the full FOIL, or you'll miss some terms. Now, yes, I know some of you can FOIL it in your head. More power to you. I'm just going to go ahead and write it down. I'm going to run the 3 through. We can at least, I guess, get that done. So let's start foiling the a plus h together. Did I mention to write small? Okay, so I'm going to do a and a. No surprise there, we have a squared. For the sake of space and time, let's combine our middles and just do it. 1ah, another ah. So I'm going to go 2. H and h squared. Yes, I still have to distribute 2 through that. Okay, I'm going to do it. It's going to be okay. We got it. Distribute 2. 2a squared plus 4ah. My arm's starting to hurt. Plus 2h squared plus 3a plus 3h minus 1. Yeah, that's nice. That's really, really nice. I scrolled too far, kids. I scrolled too far. Really love it. Okay. Take a look at all those terms. Are any of them like? No. Okay. More room. Okay. I'm on this part. Now, part C is actually what we refer to as the difference quotient. Difference subtraction quotient, the fraction mark. We have all the information up here we need to do part C. Okay. So look at what C is. F of a plus h. Hey, that's this giant green answer we got. Dear God, I'm going to write it again. I'm going to try to sneak it in here. 2a squared plus 4ah. I feel like I should be writing smaller. I'm going to switch to red. Minus f of a. Hey, I got that answer right over here. I'm going to copy it. I'm going to try to sneak it in. I'm going to put it in parentheses because we're subtracting the whole thing. So 2a squared. Let me move this over. Okay, plus 3a. Bless you. Woo! And of course, we're still all over h. Lord, help us all. Okay, look at the top. There's some stuff that's going to cancel. This is going to come out pretty dang nice, okay? So let's simplify. What's 2a squared minus 2a squared? 0. Let's cross them off. Hasta la vista. What's 3a minus 3a? Okay, we're getting somewhere. What's negative 1 minus negative 1? Okay, all right. So I'm going to write down what's left, and let's see if we can do any more simplifying. We have the 4ah, the 2h squared, the 3h over h. What's the very last thing you could do to get your final answer? Yep, take h out of everything, and we're done. Okay. So h is out for a. I'm going to take an h out. Take the h out. We're at 3. Of course, you'd be over 1. Who needs over 1? I'm not writing over 1, plus we're tired at this point. Whoo! That was fun. Difference quotient comes into play when you take calculus. You do a lot of it with limits. That's why we practice it now. So here we go. Here we go. Are we ready? We're going to do a couple more. Are they all this bad? No. Okay. Find the indicated difference quotient and simplify your answer. Now notice this last one, I'm very, very nice to you. I had to do it in 3 separate parts and we just did the answer at the very end. It's the same process. I just didn't get crazy and write it out into all separate parts. But I'm going to kind of do the same thing. I'm going to start with this. F of x plus h. So I'm going to have to put x plus h in for both of those x's. I'm going to write it underneath. So I'm going to do x plus h squared plus x plus h. Now here's the gross part. This darn quantity squared. Write it twice, we get FOIL, I guess you can combine like term. Okay, so it's just a lot of algebra. The setup was easy. My arm's starting to hurt, I need longer arms. Okay, I'm gonna scroll this up a little bit because I feel like I'm getting to the bottom here. So, oh boy.
I'm sorry for the interruption to Abigail in class.
Yes.
Could you research at Helen's office, please?
Sure. So, yep, x plus h, and then h squared. Oh, yeah. Are anything up there? Let's take a mental break here for a second. Is anything up there in red, or any of those like terms I could combine anything? No. Okay, great, good stuff. Okay, so let's work on this. So I just figured out the f of x plus h. I'm just gonna slap it up there. Okay, I got my x squared, my 2xh. Man, this is obnoxious, right? We got it though. Whew. I'm on this part now. Let me give you a second to write. Minus f of x. I know what f of x is. Look at it. Read it to me. What's f of x? Yeah, we just got to subtract that off. And of course, we're over h still. Whew. So obviously, I think it's going to work out kind of like the last one. Some stuff's going to cancel. It's going to simplify. It's not going to be that big of a deal. Because x squared minus x squared cancels. X minus x cancels. I'm going to write down what's left. And obviously, you're taking one out and you're done. H. I'm going to have 2x. I'm going to have a single h. Don't forget 1 to hold the place, otherwise you'd be missing a term. We don't need over 1 unless you really wanted to write it. So, time consuming, definitely time consuming. But difficult, I don't know about that, but very time consuming. Okay, last one. Now, I'm only doing a couple of these with you because this is part of the harder stuff of the assignment, but I did take a little pity on you on this one. Because look at your function. 2x. There's no squared. There's not going to be any FOILing. I mean, I can times by 2 pretty quick, people. Okay? So same thing. First, we're going to start with this guy. So we're going to have to put x plus c in there. Now, we can do that in our heads. 2x plus 2c, right? Winning. We're winning. Took a little pity on you. So I'm going to go ahead and put that in my difference quotient fraction up here. Got it. No FOILing needed. Happy day, happy day. Now I'm on this part. Easy. Read it to me. What's g of x? And we're over c. Final answer. 2. Obviously, I did a couple of the more complicated ones, but there are some very simple ones too. Any questions on that? That's probably the only, honestly, new thing I have for you this chapter. A lot of it's review from Algebra 2.